Hi everyone, welcome back to my YouTube channel. So in previous video, we learned the Kahn's algorithm to arrange the node in topological order. And in today's video, we will learn how to detect cycle in a directed graph. So just to revise, what is toposort? So it is nothing but linear ordering of vertices such that for every directed edge from U to V, U always appears before V in that particular order. So if a graph contains cycle, as we all know that topological sort only exists for directed acyclic graphs and it does not exist for cyclic graphs. So if a graph contains cycle, for example, so it is practically impossible to generate the topological sort for a cyclic graph because every node in this graph depends on another node to finish first. If we consider 1, it depends on 3 to finish first. If we consider 2, it depends on 1 to finish first. And if we consider 3, it depends on 2 to finish first. So there is a cyclic dependency and it is impossible to generate topological sort for this particular graph. So the core intuition to find out whether a directed graph contains a cycle or not is that if we can successfully generate topological sort for all the nodes in the graph, then it conveys that the graph does not contain any cycle. For example, if a final topological order contains all the nodes, like all the 4 nodes in the graph, then it says that there is no cycle in the graph. But if our final topological sort contains fewer number of nodes than the total number of nodes in the graph, then it conveys that there is a cycle in the graph and that we were only able to process only fewer nodes in the graph. Now let us understand why does this algorithm works. First, we will find out the in-degree of all the nodes in the graph. So in-degree of 1 is 0 because it has 0 incoming edges. In-degree of 2 is 2 because it has 2 incoming edges. One is coming from 1 and another is coming from 4. So in-degree of 3 is 1 and in-degree of 4 is also 1. So as per Kahn's algorithm, we simply push the node with in-degree 0 inside the queue. So since 1 has in-degree 0, we will push it inside the queue. Okay, now we will simply iterate over queue and process the nodes. So the front node in queue is 0. Now what we will do is we will remove 0 from our graph and reduce the in-degree of its adjacent node by 1. So since I'm going to remove 1 from our graph and in order to remove 1, I will have to remove this edge. Okay. Now since I have removed the edge from 1 to 2, I will have to reduce the in-degree of 2 by 1. Okay. And we have processed all the adjacent neighbors of 0. Oh, I made a mistake. Initial node was 1 and not 0. So since I have processed all the adjacent nodes of 1, okay, and now our queue has also become empty. So our algorithm will come out of the loop. But as of now, we have got only 1 in our topological order, and which is lesser than total number of nodes in the graph. So the total number of nodes in the graph are 4 and we have got only 1 in our topological order, which is lesser than total number of nodes. Hence it conveys that there is cycle in the graph. So now let us understand the code for this question. Since in this GFG question we are given a list of edges, first we will create an adjacency list from the list of edges. So since there is a directed edge from U to V, hence V is the adjacent node of U. So we will simply push V. Now, okay, and we also need to create an in degree vector. Now we will calculate the in degree for all the nodes in the graph. Now we will push all those nodes which has in degree equivalent to 0 in our queue. And we will also maintain a counter variable to store the count of nodes that are present in our topological order. And now we will iterate over a queue to process the node until our queue is empty. Now we will pop the front node from the queue. Now we will process the adjacent node of front node. And we will reduce the in degree of its adjacent node by 1. And if at any point in degree of the adjacent node becomes equivalent to 0, we will simply push it inside the queue. And at last, if count is equivalent to V, then it conveys that the graph does not contain a cycle, and hence we will simply return false. Otherwise, we will return true.